This is a video for AQA Discrete Mathematics, Graphs and Networks, section 4.6, which looks at flow augmentation when we've got networks with upper and lower capacities. In a previous video we considered this particular network where we've got upper and lower capacities. So for example SD there, it must have a minimum of 5 flowing through it and a maximum of 12. We can get an initial flow by firstly allocating the minimums to each of the arcs, so 5 and 3, 1 and 1, etc., but making sure then that it is a feasible flow. In other words, you've got to look at the fact that at A we've got 3 flowing in but only 2 flowing out. So say a previous video considered that, and we ended up with the diagram on the next slide. So this is our finished initial flow, and you can see that we've got a total here of 4 giving 12 flowing into T, and likewise 7 and 5 flowing out of S. So 12, an initial flow here of 12. The question would be then, is this a maximum? Well, we can have a look, and clearly not, because you can see, for example, that from S to D, C and T, these are not at their maximum capacities. So we've got a capacity of 12 on SD, on DC 14, and CT we've got 13. So we're not at capacity yet. So we now need to look at flow augmenting paths to see if we can make improvements to the current flow of 12. To do this, we need to set up the diagram as before by looking at the potential changes that can take place on each of the arcs. So for example, if you consider arc DC, we can see at the moment there is a flow of 8, and that's its minimum, so we can't actually reduce that one by anything, so that would be 0 from D to C, going backwards, but we could increase it by 6. Consider on the other hand SD. At the moment there is 5 flowing, so again we can't reduce that one, so that would be 0, but we could increase it by 7. Now look at SA. From S to A we've got a flow of 7. That could be decreased by 4, bringing it down to the minimum of 3, and could also be increased by 4. So we're producing now a diagram like this one, which shows the possible increases and decreases on each of the arcs. What I'd like you to do is to pause the video now and just to complete this on a piece of paper for yourselves before we move on to the next slide. So if you pause now and just see if you can complete it. Well, here is the completed diagram for you to check. For example, let's look at B to T, where we had a flow of 4. It has a capacity, maximum capacity of 10, so we could increase that by 6, but we couldn't decrease it by anything, so 0 here is the reduction. Notice that these numbers no longer add up to the capacity of the arc, but you can get the flow by looking at the 0 here and adding it to the minimum capacity 4. Let's look at that for a different arc. Let's say the arc from A to B. What's the flow in this one? Well, we can look at the possible reduction, which is 5, and add it to the minimum, which is 1, to give us a flow of 6. So a little bit more difficult to use this diagram to decide on the actual flow. However, we can use it just the same to work out the flow augmenting paths. We've already said that there is a flow augmenting path from S, D, C and T, and if we look at the numbers on that, you can see that we've got 7, 6 and 5, so we can add 5. The procedure once we've got that 5 is exactly the same as before. The forward facing arrow reduces by 5, the backward facing arrow increases by 5. D to C, therefore that's going to become 1 and 5, and from C to T that's going to be 0 and 8. The 0 there indicating that that arc CT is now saturated. So we could look for other flow augmenting paths, but if we go from S to D, you can see we get from S to D. We could go to C with 1, but we then saturated from C to C, so that's no good. And coming the other direction, B to D, it's 0 in that arrow there, so that's no good. And from D to A, again 0 facing towards T, the sink. So our only option now is to come from S. We could go from S to A, could go to D, C, but that's not going to be any good. So our only real option is to come S, A, B and T. And you can see we can increase by a maximum of 2. So our next flow augmenting path is S, A, B, T and adding 2. So the forward facing arrows are going to come down by 2 and the backward ones up by 2. Forward facing down, backward up, and again forward facing one comes down by 2 and the backward facing arrow goes up by 2. So there's our final diagram from which we can work out the flow. Well, we knew that we had a flow before of 12, we've added 7, so we must now have a total flow of 12 plus 7, which is 19. But remember, this diagram doesn't give us the flow along each of these arcs, and that's what we need to work out now. But we can get that by adding each of the backward facing arrows to the minimum values. So the flow in BT is now 2 plus 4, it's gone up to 6. So the diagram doesn't give us the actual flow along each arc, but it tells us the potential decrease, and we can add to that the minimum, and that will give us the flow on each of those arcs. Let's look at that for the rest of the diagram. If you look at S to D, there's a backward arrow of 5 and a minimum of 5, giving a flow of 10. From S to A, backward 6, minimum 3, so the flow is 9. That gives us our flow of 9 out of S. 19 out of S. The 9 going into A splits into 8 and 1, and that 8 splits into the 6 that we've already found from B to T, and 2 going from B to D, giving a total of 13, which we can check from the backward 5 and the minimum 8, and that 13 continues from C to T, giving us a total flow into T of 19. Well, to prove that that is indeed our maximum flow, then we can use the max flow min cut theorem. So we're looking for a cut of size 19. Now remember that one of the things to look for is that the cuts will go across the saturated arcs. Our saturated arcs are from C to T and A to B in particular. And so a cut doing that would come through these arcs. So we've got the cut there of size 8 plus 13, but we must subtract the minimum on the arc which is going from the sink into the source. So in total we've got 13 plus 8 minus 2, which is indeed equal to 19. So we've found a cut which has a capacity equal to our flow, therefore the flow must be a maximum flow. This idea in general is that the cut is going to go across saturated arcs which are going from source to sink, and those where the flow is a minimum. So you can see that the flow from B to D is a minimum when it's flowing from the sink set into the source set. Well, that concludes this video. In the next one we'll be looking at the idea of flows on networks which have restrictions.